In the name of Allah, the Beneficent, the Merciful. Welcome to the world of physics. Due to coronavirus, we have to continue our online class. At first, I would like to suggest you stay home, stay safe. Let me introduce. I am Mohammad Muqtadir Hussain Bhuya, lecturer, Department of Physics. And at first, observe this diagram. And observe this diagram too. Now think what you have observed in this diagram. By observing previous diagram and this diagram, we can guess the name of the chapter. Yeah, actually, all of you know that which chapter we are going to discuss, and this is the second lecture on on this chapter. And observe this diagram too. Here, some of the colors are blinking, and think what you have observed and what's going on here, and what can be happen inside of this object, and what's the reason behind of it. And I think all of you can guess by observing these three diagrams, you can guess the name of the chapter. And here, this is our last lecture on this chapter, and the name of the chapter is Refraction of Light. And today we are going to learn about all of these topic, that is image, real and virtual image, refraction of light, law of refraction of light, and formation of image in a concave and convex lens. These all are the topics that we are going to discuss, and learning outcomes for this lesson. And by the end of this lesson, you will be able to explain lens with diagram, explain image with diagram, explain the formation of image in concave and convex lens. These are the learning outcome. At first, we are going to compare reflection of light and refraction of light. That is, here in reflection of light, we consider consider a plane, and this incident ray, and this ray is a reflected ray. And for your better understanding, we take highlighter. Here, this ray is incident ray. This ray is incident ray, and this ray is reflected ray, and this is a plane. And here incident angle is I, and reflected angle is R, and these all are same. And in refraction, the light ray will refract through this through another medium, and here the incident angle is also I, and reflected angle is denoted by R. And here we have two medium, that is one medium, one of them is air medium, and another medium is water medium. And here the light comes from air medium is called incident ray, and the light ray uh, refracted through water medium is called refracted ray. And this is the difference between reflection and refraction for any light. And by this diagram, we can compare reflection and refraction. And today, in introduction to refraction of light, we will be able to explain and know the definition and all these explanation. Here first, we're going to discuss about what is refraction of light, and what is Snell's law, application of reflection of light, cause of reflection of light, effect and example of refraction, and refraction in lenses. These are the learning outlines, and we are going to introduce with all these topics to you. And key feature of refraction is refraction plays a central role to form an observing image in the lens, eyes, sound, water, and focal length. In Huygens principle, the blending of refraction can be visualized in a slower medium. Speed of light is reduced, and the wavelength is equally shortened. And index of refraction talks about how the speed of light in a medium is divided by the speed of light in vacuum. The formula is n equal to c by v, where in vacuum v is the velocity of the light, light medium. And here in Snell's law is a vital component to understand while exploring what refraction of light is. This law gives the angle of bending ray of light on the incidence of refraction to media. This law can be derived from Fermi principle also, and from Fresnel's equation. Uh, and here the law is the formula of Snell's law is n1 by n2 is equal to sine theta 2 divided by sine theta 1, and the ratio of the sine of the angle of incidence to the sine of the angle of the refraction is constant, and that is called a refractive index. And application of refraction light is the refraction is applicable in optics as well as in technology. However, it mainly depends on the type of the spherical lens, be it convex or concave. A lens is used for refraction in order to form an image like magnification, and the application of refraction is Vivgier, with how a white light passed through a glass prism splits into spectrum of color. Here, uh, uh, this uh, uh, this topic is the explanation that we have seen a diagram. Um, After starting the class, we observed three diagram, and in one diagram, we have seen that white light ray is splitted in different color. That is Vivgeo, violet, indigo, blue, green, yellow, orange, in red, and these spectrum of color are the are happen due to the refraction of light, and twinkling of star mirrors is the prime example of atmospheric refraction. And a cause of refraction of light is when the refracted rays frequency remains the same, the intensity of the refracted ray is less than the incident ray due to the partial refraction and absorption of light at the interface, and in two different media. When light crosses the boundary, the deviation of the light takes place. It occurs refraction when the wavelength of light and its speed varies, and this is the application that happened only for because of refraction. And here your color is splitted from white light ray. And effect on example of refraction is as mentioned before, refraction can be witnessed in terms of optics as well as in technology, as twinkle due to the refraction of light, and mirrors as well as looming are the optical illusion caused by the refraction of light. And light in swimming pool refracts and gives its silver look when the straight light strikes at the bottom and bend at again the water surface, causing refraction of light. And the rainbow formation as well as a prism are also major example of refraction. So is the prism that we have seen previously. And here one thing is I should say, that is we are actually we have ideas about refraction, and now we are going to show you some example and application of refraction and effect of refraction, and Snell's law, and whenever that is related to our topic. And I think all of you know all these topics that we have discussed previously also, and in another language we also explain all these terms here. And let's discuss about lens and image, and refraction in lens. That is lens, we all know about it. And here lens are carbon shaped and are useful, useful also, and it's usually two type, concave and convex lens. In a converging lens or concave lens, the light enters and refracts inwardly and equally refracts at the time of its departure. It causes the parallel light rays to spread out while travels directly from the imaginary focal point. And here the images are two types, that is real and virtual image. And real image, this is the definition of real and virtual image. We got real image in concave lens, and virtual image for virtual image for concave lens, that is diverse happened because of divergence. And for convergence we got uh, real image that happened for convex lens. Okay. uh, Actually we are going to discuss all this. And here lenses are used to focus light and form image. And there are variety of possible types, and we'll consider only the symmetric ones, and the double concave and double convex, that is. And there are three type of concave lens and three type of convex lens. And concave lens is called converging lens, and converged lens is called there is diverging lens. Here uh, con, uh, concave lens are uh, converging lenses are concave convex meniscus, and plano-convex, and double convex. Actually, this is important for us. We are going to discuss about only double convex lens. And concave lens or diverging lens is also three types, that is concave meniscus, or convexo concave, that is also called, and plano concave, and double concave. These all are the three types for diverging lens. And here for a double convex, that is converging lens, the light refracts such that it converges at the focal point. And here F is the focal point, and this lens is converging lens, and is also diagram for double convex lens. Actually, we are not going to discuss about plano concaves, plano convex, and convex to concave. And we are only discuss about convex lens, that is converging lens. And after convergence, light ray uh, is light ray is come to a point, that is a focal point. And a double concave lens, that is double concave lens, that is diverging lens, as a refracted ray diverging as if they come from the focal point, and F is the focal point, and the ray diverges after diffraction. In this diagram we also see that the refraction happened after refraction, the divergence happened in this lens. And this lens is also called concave lens. And we are going to construct a ray diagram for uh, uh, we're going to draw two of the three principal rays originating from the same point on the object, and follow these rules. That is one, that is a ray that is a ray diagram, ray drawn through a point on the object and parallel to the principal axis. And here it is refracted through the focal point. And if the ray through the point of the on the object, and through convex or towards concave, towards concave the focal point, and it is refracted parallel to the principal axis. And rule 3, that is ray is drawn through the point on the object, and through the vertex, and it goes straight through and doesn't change its direction, assuming lens is thin. And these are the three rules for drawing a ray diagram. And here precisely we the three all these three ray diagrams can be shown with this figure. And for ray 1, if the ray is parallel, if the ray is parallel, then it go through the focus. And if the ray go in the if the ray 2 is go through the focal point, then it refracted in parallel direction. And if the third ray, that is go through the optical center, then it go in the same point, in the same direction, and it will not change its direction if the ray 3 is drawn. And it's a double convex lens, and it is also called converging lens. And image types for converging lens, that is the convex lens from different image types depending on where the object is located with respect to the focal point, focal point. And here converging lens is equal to convex lens, that we know. And 5 possible object location is happen. Case 1, the object is located in front of focus. And case 2, the object is located at the point 2f. Case 3, the object is located beyond band 2f. And the case 4, the object is located between f and 2f. And case 5, the object is located at f, the focal point. These 5 possible location. And in other way, we can also add another position, that if the object is in infinite position, is also we can say. Actually, the 5 possible object location is possible. And here the 5 cases. You can take a screenshot or pause this video here, and look once again the 5 cases and 5 position of the object. And for this 5 position, we can draw the image for this 5 position. And here please complete a handout for concave lens front half. That is 2 example are done for you. And next slide to help you get understand. And here uh, case 1, if the object is located in front of f, here this is the figure. Here the object is in red color, and object is located in front of f, that is the object is shown here. And for this object we get an image that is a here we can draw the image by drawing a ray diagram. Here first law is, if the ray is parallel, then the refracted ray go through the focal point. And second law is, if the ray is if the ray go through the optical center, then it will not change its direction. That's why after joining these two line, actually it doesn't meet in the forward direction. That's why we go through the backward direction, and we get this point. And this is the image, and it's a virtual image for this lens. And actually this is the virtual image. Okay. And here notice here that for location, you telling me what side of the lens the image is on, and same side or opposite side as the object. And here L for same side of lens as object, and O for upright, S for large, and T for vertical. Just note this. Keep in mind this L, S, O, and T. This for the position. And here if the case 2 is happen, object is located as 2f, And here our first ray go through in parallel to the principal axis, and we get a ray that go through the focus. And second ray is if the ray go through the principal focus, and then the refracted ray we get that is parallel to the principal axis. And third ray go through the optical center, and it will not change its direction. That's why all these all these three uh, all these three ray centered in a point, that's why we get an image. And this is the real image, because all these three three incident ray intersect in a point, certain point, and it really happened. And that's why this is this the that's why this is real image for this object. And uh, here this also here at 2f the object is alpha it is happened the image is in opposite side, and it is inverted, and it is equal to the object, and the image is real. For these here you also see all this information here. Image in opposite side, here the right side image is just opposite side of the object, and it is real inverted, and as the size of the object and the image is same, and all this information we can show here. Here the image is in opposite side, and it is inverted image, and it is equal to object is equal to the image, and it is real. And here another here we we also uh, show you we can draw a ray diagram for ray diagram for concave, yes, concave lens also. Here it is a double concave lens, that is diverging lens, and concave is similar to diverging. And for ray 1 here the ray is parallel, and that's why it comes from a point that is parallel to the here parallel to the here the comes from a point that is parallel to its direction. And ray 2 that is uh, incident in an inclined way, and after incidence it will refract it in parallel direction. And here the direction of the incident ray is towards focus, that is ray 2 ray 2 is incident towards focus, and ray 3 is similar to the as we said previously. If the ray go through the optical center, then it will go in the in the same direction, and here the direction will not change. This is the three ray diagram for concave lens, that is for divergence lens. And here look at the image of an object located, and there is between f and 2f for divergent lens. Here the object is located, mm, uh, that is between f and 2f, and by drawing three ray diagram we can draw image. By drawing three ray diagram we can find the position of the image. And here the position of the image is found, and it is a virtual image. And it's the image is same side of the object, and it's virtual, and the image is contracted. And here the position of the image is in between optical center and focus. And here to draw the position of the image we also three ray diagram, that is ray 1, ray 2, and ray 3. And by using ray diagram rules, draw ray diagram here, and finally we got the position of the object, position of the image, and the position of the image is in between focus and optical center, and this is upright and contracted image, and it is virtual. All this information we can say. And here diverging lens, that is complete the ray diagram for concave or diverging lenses, and you only need to complete 2 or 3 of these. If you catch into the thread, you can stop and complete the summary table for image properties for of diverging and converging lens, that is shown in our next slide. And you can take more time here. You may take 10 to 15 minutes time I'm giving you. Pause the video here and take 10 to 15 minutes time to complete all these all these uh, information here, and try to fill up this table. And if you able to fill up all this information in this table, then I think you can you'll be able to draw all these diagrams, and that is related to our topic. And I hope if you're able to complete this table, then you will be able to solve any kind of problem. Here the position of the object is given here, and then you have to write the size, altitude, altitude and location, and type. All these information you should complete. And you may have some question. Before asking question, I'm reminding you once again, take time and complete this table. And if you find any difficulties, then ask me in our class time or any other time. I'm available for you all. And you have to be cautious about coronavirus. And thank you for joining with us, and take your time. Thank you. Allah Hafiz.